Alright, my friend, we are gonna resolve the first word problem. Basically, we have to write a program that takes a string and displays its first word, followed by a new line. A word, what is a word? Well, is a section of string delimited by spaces and tabs, or by the end of the string, of course. If the number of parameters is not 1, or if there are no words, simply display a new line. So we are dealing with a program that is taking inputs from the command line. Let's jump into the code. As usual, we're gonna open our terminal, so command space iterm cd desktop vim first word.c. Cool. As usual, the constraint is to use only the right system call, so we include the Unix std header file, and then we declare our main function. Argument counter, char star argument vector. I can write here like that. That's totally the same. Here we are. So you need to have a very good understanding of command line arguments. I prompt you to watch a video that I've made if you don't understand what is going on. So immediately I see that the program wants, if the number of parameters is not 1, or if there are no words, simply display a new line. So action only happens if 2 is equal to argument counter, right? Only in this case something happens, otherwise we just print a new line. So this is gonna be the core of the main, and here I just write a new line, right? So standard output file number, I have my buffer, which is a new line, and it is only 1 byte. Cool. So I have to write the first word, and a word is something which is delimited by a tab or a space. First of all, I want to skip all the spaces, right? I want to skip all the spaces that I may stumble initially in the string. And of course, I have also to skip all the tabs. So I'm gonna declare an iterator here that I call I. This is the classic name for iterators, and I assign the value 0 to this iterator. And I say, if the char pointed by the string that I'm looking for is a space or it is a tab, you just go on. So how do we write this in code? I have argument vector in position 1, which is the string I'm looking for, in position I, is equal to what? Is equal to space. So here you can write directly a space in its symbol representation, or you can write the ASCII code, which is 32 for spaces. It's very easy. You can write on the ASCII code just doing man ASCII. As you can see, the 32 is the space, and the tab is the number 9, so horizontal tab. So here I use the 32, then I say, or the char pointed is a tab, or again, argument vector, position 1, position I, is equal to, this time I'm going to use the symbol, which is this one, tab, right? Here I could have written 9, you understand, right, the point. If it is the case, you just keep going on. So ask open ++ I. So I is going to increase over time. I just want to skip all the spaces, all these tabs, if there may happen to be, right? All right, now you skipped all the tabs and the spaces. Now you may stumble in a chart, something that you want to write. So here we say, while what? While argument vector, position 1 and in position I is different, right? This time from space. And of course, the same logic for the tab. So copy paste tab. This time I'm using the 9 to prove you that it is exactly the same. So you have this condition that I want to close in braces. So if the chart pointed is different from tab and space, and again, I need to say, and we are not at the end of the string, right? So, namely, this is not the \0. I can say argument vector in position 1, in position I is different from 0, but now you know very well that this is redundant. I can also simply say like that. Basically, here there's written, and the string is not finished. What do? Well, I want to write this stuff, okay? So I'm gonna use write 1 for the standard output, and then I need to give a pointer, which is argument vector in position 1 plus I. I will explain you better this point. 1, okay? And of course I have to increase I every time. So just to make it simple, I'm gonna do like that. Curly brace closing, and ++ I. So here I just have to put semicolon. So here basically with this very strange while loop, I'm saying while the chart pointed by the argument vector in position 1 in position I is different from space, and it's different from tab, and that char is not the \0, what do? You just write. Everything that is not tab or space, you just write. So this is gonna decay when we stumble upon a space, a tab, or the end of the string. That's it. And we are done. Basically, that's it. Now let's try to launch this code and let's see if it works. Maybe there is some bug somewhere. So I'm gonna compile first word, and then I'm gonna launch a.out, space, hello there. Allegedly, it should write only hello. Let's launch. Nothing. Something is wrong with my code. Do you see any mistakes? Oh yeah, of course. What a stupid. Here I need a while, not an if. Because of course, if I have many tabs or many spaces, such a dull mistake. Okay, let's recompile the code. First word, and then let's launch. Out. Hello there. Some spaces initially. Here it comes. I have my hello. Hello there. Seems like it's working properly. Let's try to remove this hello. This is empty. Just a new line. Nothing, a new line. And yeah, it seems overall that the code is working as asked to. All right, this is the code. Now let's try to understand better what is going on. First word. Here you have to understand very well what is going on with the argument vector. So I prompt you again to watch my video. Maybe the most difficult part of this is to understand what is going on here. Well, you know very well that the write function, system call function, requires a buffer here, right? So what is happening with that piece of code? Well, basically, this is a dereference, right? AV, the reference in position 1. It's like saying dereference AV plus 1. The square brackets are just a syntactic sugar, right? What is really happening is dereference. And then to that, I just had I. When I dereference this boy here, I get another pointer. I get another pointer, which is a pointer to the string. Indeed, I have a pointer to a pointer. So when I say, give me what is inside AV in position 1, and say, give me the pointer which is in that position, and then add to that pointer I. Basically, I'm doing pointer arithmetic with the string, and write wants exactly a string. So every time I get the pointer that it's pointing to the next char. Again, to understand this code, just have a very good understanding of what is going on with argument vector. And for the rest, I think it's super easy. What do you think? All right, that's it for this video. Thank you for watching. Enjoy. All right, my friend, today we're gonna do another exercise together, and this time is gonna be fizz. Basically, we have to write a program that prints the numbers from 1 to 100. Each number has to be separated by a new line. If the number is multiple of 3, we have to print fizz. A multiple of 5, buzz. Of both, fizz buzz. All right, let's jump into the code. So as usual, let's open our terminal. I use iterm, but you can use your pre-installed terminal. As a shell, I use fish, but now I'm gonna use bash, because probably is the one you're using. I change inside my desktop, and here I just create my program, fizzbuzz. So vim fizzbuzz.c, enter. So for this problem, we have the constraint that we can only use the write function. I've already explained in a previous video this system call function, so maybe you can check it out. To use this system call function, we have to include the file uni.std, Unix standard. So we're gonna press I to change into insert mode, and then we include uni.std.h. All right. Basically, to know this stuff, you just do. We ask from here, man to write. Okay, I have to write in this fashion. Now I'm gonna explain you why. Basically, we want to use this function here. As you can see, here we have the prototype, here we have the description, thanks to the manual. Why to? If you say man, you can see that the manual is divided into some sections. Section 2 is for system calls, and the write is essentially a system call, so we need this section of the manual. If we write, for example, man write, we go in another section and we get a different write. That it is not what we are looking for. Okay, easy. All right, fizzbuzz.c, and we start with our algorithm. As always, we start from the main function, all right, which is the access point of all the programs in C. And now we understand what we have to do. Basically, we have to write a series of numbers from 1 to 100 included. If the number happens to be divisible by 3 and 5 or both, we have to write something else. So we start from the number. We say int mbr, this is the declaration, mbr is equal to 1 because we start from 1. Then of course we're gonna need a loop. We're gonna check for different combinations. So I say while something, open curly braces, okay? What is the condition? Well, the condition is that the number is minor 100, but not only minor, it has to be minor equal because 100 is included, right? Cool. So until the number is minor equal 100, what are we gonna do? Well, we have to make our checks. We have to check if the number is divisible, first of all, by both, right? First of all, I have to check if it is divisible by both 5 and 3. So I say if, how do I express if a number is divisible by another number? Clearly divisible. Well, I just check the remainder. If the remainder of the division is 0, it means that we have a clear division. Easy peasy. So I say if number modulo 3, in this case, this is gonna result in 0, right? So I can say is equal to 0, but I think this is not super elegant. I can do in another fashion, which is cooler. Just simply say, if this operation holds 0 or 1, I just reverse the logic of that, because you know that in C, 0 stands for false and all the other numbers stands for truth. So we can exploit the result of this operation. If the result is gonna be 0, I'm just gonna reverse the 0, which is a false, into a truth value. So this is gonna become true. Here is written, if the number is clearly divisible by 3. Written in C, okay? Cool. Now I do the same with 5, because I have to say, if the number is clearly divisible by 3 and it's clearly divisible by 5, so I just do the same, mbr modulo 5, ask open curly braces. What do we do if we have a clear division both by 3 and 5? Yeah, I forgot to put and. So, and here we are. In this case, what do we do if you have a clear division both by 3 and 5? Well, we have to write fizz buzz. So we exploit the function write. I say write, open braces. Here I need a file descriptor. I repeat to you, just watch my video if you don't know what it is. Here I just simply say to you, we can use both 1, which is the value for the standard output, but also we can use a symbolic constant, which is standard output file number. It's the same. This is more readable, I would say. Then we need a buffer. Basically, we need a pointer, which is this literal string. Basically, we say fizz buzz, okay? And a new line. So it's gonna be 4, 8, 9 chars. 1 char, you know perfectly well that it is 1 byte. So the next number byte parameter is gonna be 9, because here we have 9 bytes. Basically, this is a buffer, an area of memory, which contains 9 bytes. I want to flush all of them in the standard output, thanks to the write function, okay? Semicolon, finish. Now, when we have only 1 line inside the block, I can skip the curly braces, okay? So I'm gonna delete them to make the code shorter, more compact, and I would say more readable. Now we have to check for the other conditions, basically, else if what? Else if the number is only divisible by 3. So again, I'm just gonna write the same piece of code. In this case, ask open, what do? We just write, here I'm gonna write only 1 to prove you that this and this are totally equal. This time we have to write only fizz, right? So fizz, new line, and the chars, the bytes are gonna be 5, right? Semicolon, because here we have 5 chars, namely 5 bytes. Okay, ask open, else if, other condition, what? The number is divisible by 5. Ask open, what do we write? We are gonna write 1, only buzz, right? Buzz, new line, still 5 bytes. Else what do we have? Else is the branch in which we have all the other conditions which are not met previously. So we say else, we have to write the number itself. Now we have a riddle, because we have to write a number, but the write function is taking only pointers, is taking only strings. So we need a special function that is able to print in the standard output numbers. So we say my put mbr, okay? That takes as an input the number itself. we're gonna define and implement this function. All right, at the end, I have only to increase number, right? Plus plus mbr. This is the core of the code, right? It is pretty important to start before everything with check if the number is both divisible by these two. Because if we start, for example, if the number is divisible by 3, we get the number 15 as an input. What is going to happen? Well, I'm just going to print fizz, right? And then that's it. It's not going to perform anything else because we entered this specific branch. So first of all, check if the number is both divisible by the two numbers. For example, 15 enters inside this loop. I'm going to write this one. If I get, for example, 6, I'm going to enter inside this branch. Otherwise, if I have 5 or 10, I'm going to enter inside this branch. You get the point. The order is critical, and it is the core of this exercise indeed. Now I need my put number. All right, let's make it a little smaller, and let's go here. This function doesn't return any value, of course. It is just an action, because every function can perform an action, return a value, or both, okay? This function doesn't have to return me anything. So void. Now I write the name tag of my function, so my put number. And as an input, it takes an integer that we call mbr. You can call even n. I recall to you that this variable is different from this one, because we pass variables by value. Basically, they are copies. Because when we pass a variable here from here, we have a copy of the variable. Basically, they are totally different. They are in different parts of the program. This variable is inside the main function, while this one is in another scope, basically my put number scope. So what is inside my put number? Well, I need to write, I repeat to you, this value. How can I achieve that? First of all, I'm going to declare a char that I call temporary. And now you will understand very well how I'm going to use it. I say, if if the number is minor than 10, basically if the number has only one digit, that's very easy, right? Ask open, what I'm going to do? I'm going to say temporary, which is my char, is equal to what? Is equal to the number plus 48. Or here I can say also plus 0, the char 0. Why is that? Let's get out and let's watch the ASCII table. I say man ASCII. As you can see here, I have my decimal set of the ASCII table, and the char 0, the symbol 0, the draw. What is that? Well, is the value 48. You can see here that I have all the symbols representing a number from 0 to 9. So if I say the number, the value 48, I'm talking about the symbol, the draw 0. So how can we convert a value, an integer value, into a char, into a symbol? Well, it's fairly easy, my friend, right? We just perform the code I'm showing you. I take the value, for example, if I have the number 7 and I add to it 48, I get 55, right? What is 55? Well, it's 7. It is the symbol 7. So I need that value, that specific value. So coming back here to the code, here in my temporary char variable, I'm gonna stock the char I want to write, okay? So if the number is minor than 10, it's pretty straightforward. I'm just gonna write in the standard output file number what? Here I need a pointer, right? Here I need a buffer. So I need to give the address of TMP, the address of the char that we just created, and then 1, because we have only one char. Easy. So when the number is minor than 10, easy peasy. On the contrary, here we are sure that we have a number which is 2 digits, right? Because in my very short program, we are dealing only with numbers ranging from 1 to 100. So this my put number is an ad hoc function for my special case. Now, this time I can do like that. I say temporary, so my temporary char is equal to number divided by 10 plus 48, okay? Now I'm going to explain you why. If I have, for example, the number 52 and I divide it by 10, I get the value 5, right? Because I have truncation in C. Cool. So here I get 5 plus 48. So let's write it down. I'm going to do 52 divided by 10 is going to be 5. 5 plus 48, what is equal? Is equal to 53, right? What is 53? Let's check in the manual. Man ASCII. The value 53 is equal to the symbol 5, as you can see here, right? Easy. So 53 here is 5, but it is 5 in its char representation. It is the symbol 5. Easy, right? So let's leave it here, recommend. So now I have the symbol 5, which is inside my temporary. I just simply need to write it. Write standard output file number, the address of TMP, right? 1. And then again, temporary is equal to what this time? Is equal to n modulo, this time 10, plus, this time we're going to use the symbol 0 itself. So you understand what is going on. Here I take the reminder. Let's pretend again that we have 52. 52 modulo 10 is equal to 2 plus 48 is equal to 50. 50 is the symbol 2. So I have the char. Okay, so we do write. Again, the same deal. The address of TMP 1. All right, that's it, my friend. Let's delete this. So this is my function. I just need at the end to write a new line, right? Standard output. Here I put a string which contains only one new line, 1. Okay, here it comes. Put number. This is a special function, a doc for my special program, fizz that is gonna print the number. All right, let's try to launch it. It's easy. I'm gonna compile the code, fizzbuzz.c. I have my executable, a.out, launch. Here we are. And this is the fizzbuzz program. Let's check variable if it is correct. 1, 2, 3, 4, buzz, 5. This is for 6. And when we have 15, we have fizzbuzz. You see? 15, 30, 45, and so forth. Here, the big idea that you have to understand is that you have to be careful about the order in which you call the functions. Because if you change, for example, I repeat to you, if number is divisible by 3 in the first position, it's not going to work. And another thing which is important is this one. If you all the time, you don't use else if, but you use if, all of them are going to be checked. Okay, so this is going to be checked, this is going to be checked, and this is going to be checked. Let's watch the output so you can understand better. GCC fizzbuzz launch. As you can see here, when I have 15, what is happening? I have 14, and I have fizzbuzz for the first one, fizz for the second if, and buzz for the third. So all the conditions are going to be checked, and all the conditions are going to be met. So that's why all the time we have to use else if. So they are mutually exclusive, right? One is true, I don't check the other ones. And the last thing, which maybe it's interesting, is that when I have multiple ifs, this else, who does refer to? Well, it's referring to the previous one, only the previous one. If this, and these are in couple, okay? All right, I think that's it for this fizzbuzz exercise. Enjoy, my friend. All right, my friend, let's try to do this put string function. Basically, we have to write a function that displays a string on the standard output. Here you can see the prototype. We have a function that doesn't return any value, so it is performing an action and takes as an input a pointer to a string. Basically a pointer to the first char of the string. Okay, as usual, command space. Let's open the terminal. I'm gonna cd inside the desktop, and I'm gonna create this my put str.c. str. Now the only function I can use is the write system call function. So I'm gonna include unistd, right? Unix standard.h. Perfect. As usual, I'm gonna declare my main function. It's main and all the jazz that you know. Now I create a string, a char string. So char star str or s simple, and the value of s is gonna be hello world exclamation point. Perfect. And now I need my put str, right? Now I can also print with the camel case put str, and inside I put my string, which is s. Okay, so the exercise wants to print this function. Perfect. So at the top I'm gonna write my function. I can say void because this function doesn't return any value. It performs an action. You know perfectly well that every function can perform an action, return a value, or both. Perfect. So my put str, and as an input I have a char star, okay, which is a string, of course. I open the curly braces. How do we do that? Well, basically I have to write all the chars which are inside the string until I stumble the sentinel value \0, which is appended by the compiler at the bottom of the string to show that the string is actually ended. All right, so I can say while what? While at str. So here I'm dereferencing the string pointer. So here I have the char pointed by the pointer str. is different from 0, right? What do? Ask open, open curly braces. Well, we just simply write that char, right? So I can say write in the standard output, file number. And here I have to give a pointer, right? The write function wants a pointer, a buffer. And indeed, str, it is a pointer. So I can simply give str. And then I just use 1 because the char is 1 byte. Then what do? Well, then I have to increase str. I increase with the prefix increment plus str, semicolon. So I'm doing pointer arithmetic. And basically that's it. Let's try to launch this code and let's watch if it works. So ask zz. Let's compile the code as usual, and then let's launch. As you can see, I have hello world. Of course, I have the string in the same line of the new prompt because I don't have the new line character, right? Here I can remove the different from 0 because I'm going to use directly the char pointed by str as a boolean value. Okay. Then here I can delete this increment here and directly increment str with a postfix increment. So every time I'm gonna use the value pointed by str, and then only then I'm gonna perform the increment. So I can do like that. And given that now I have only one line, I can simply remove the curly braces. 2 lines, as you can see. Then if I want to have my main at the top, I can simply do that. I can transform this into a prototype, and I can move the implementation of the function at the bottom. Okay, like that. I'm just going to use this shift here to visual. To do that, you just shift to visual, you press V, and then you highlight everything you want to copy, and then you press Y to yank all of this. And then you simply press P to paste, you see? Okay, now I'm going to undo, and I'm going to delete this. I'm going to delete with visual, I'm going to highlight, and then press D to delete. Perfect. The code works exactly the same. I just need here to remove this. And here we are. This is a more clean version. So let's go back, let's compile again, and then again we're gonna launch the code at the top. As you can see, this is exactly the same. Now I want to show you another way to solve this problem. We can exploit the power of recursion here. Let's do another one, which is void recursion my put str. That takes as well a pointer to a string, right? Okay, let's watch carefully what is going to happen. Here you can say immediately write 1 in the standard output, what? str and 1. Okay, you write your char, and then you say if what? If str plus 1, and then I do reference this boy. If at str plus 1, basically if the following char is not 0, right? Here you can say different from 0, but it is redundant. You understand this, right? What do? You call again the function, this time giving as an input str plus 1. Okay, let's try to launch, and then maybe we understand better this function. We have to say rec my put str, and of course we have to create a prototype because it is underneath the main function. So we're gonna copy this boy here, str. So I have the 2 ways of writing a string. You can see here, right? So let's try with recursion if it works. Compile. As you can see, it works as well, right? I have my hello world. Now I'm gonna show you another trick. If I happen to reverse this, I'm just going to write the write function just underneath the recursive call. What is going to happen? Compile and then launch. You see, I have a hello world in reverse. So this is a neat trick to write a string in reverse using few lines of recursion. If you struggle to understand this point, I prompt you to watch a video, a doc that I've made about recursion in which I try to explain this concept to a kid. You can copy this code, and we can go in C tutor, which is a marvelous tool to see what is going on with your code. So we're going to copy our code and we're going to launch. Now, as you can see, I have here the code, and here I have a visual representation. So I have my string, and then I call my recursive call. Look carefully. Here I have the stack, and here I have the ape. So first of all, the recursive call is going to check, is the following char not the \0, namely this one? If this is the case, just keep calling my recursive function. Let's keep going on. Boom, I call another function, this time with a different input that is pointing to the next char, and so forth. If we keep going on, look at that. I have so many recursive calls, so many. Till the bottom. Here is gonna check, is the following one different from 0? No, it is not. So what are you gonna do? You're gonna go back and you're gonna write all the you're going to go back and you're going to write all the chars starting from there. So every function that has been called is waiting its turn to go on, and it's going to write the char, right? As you can see, all these functions are going to do their job. They're going to be popped from the stack, and they're going to write everyone his own char. Boom. And I have all the chars in reverse. So long story short, I suggest to you to watch this tool carefully if you struggle to understand. And of course, recursion is not suggested for this put string. This is the best way to achieve. You don't need all these functions and to exploit recursion, which is not efficient. Recursion is a tool in your toolbox to solve specific tasks, but you should use iterations for cases like that, like putting a string in the standard output. All right, my friend, that's it for this video. Thank you for watching. Repeat alpha. This time we have to make a program that is able to take a string and display every char contained inside that string as many times as the index of its alphabetical order, right? So basically, if I have the char A, I have to repeat the char A one time. If I have the char Z, I have to repeat it 26 times, okay? All right, let's jump into the code. Command space, I turn, cd desktop, and vim repeat alpha.c. As usual, I include unistd, which is the constraint. We can only use the right function, and I declare my main function, okay? Right. As you can see at the bottom, I have if the number of arguments is not 1, just display a new line. Again, we are working with command line arguments, so you have to understand very well what is going on. If not, I just prompt you to watch my video in which I explain command line arguments. So here I just say int argument counter char star argument vector. And here the action happens only when if 2 is equal to argument counter, right? Here's going to be the core of the thing that we are going to implement. Here at the bottom, I just have a write that writes in the standard output file number, a new line, right? New line and 1, because we are writing only 1 byte. As you can see here, I have only 1 byte. Cool. So what happens if everything is correct? I'm going to say until the string is not finished, basically until I don't have a pointer to \0 char, basically while argv, that's I can write much more easily like that, av in position 1, in position well, basically I can simplify a lot this code just by doing like that to make it more readable. I say char star str, and str is equal to argument vector in position 1. Okay, so I don't need to make all the times a double dereference to get my string. I say while at str, I'm going to exploit pointer arithmetic directly with the name of the string, which is str. So I'm going to increase str and not an iterator like I. While str is different from 0, you know that I can skip this one. I'm going to use directly a char pointed as a Boolean value. Ask open, what do? I recall to you that all the chars are just numbers, right? Are just numbers are stocked inside my ASCII table. And do my ASCII. As you can see, every char has its own value. So first of all, I have to check if the char is in upper or lower case. As you can see, from 65 to 90, I have upper cases, while from 97 to 122, I have lower cases. I have to check it is uppercase or lowercase because I have to maintain this property. So what do? I say if at str, so the char pointed by str, is major equal than a. Here I can write 97, but I would argue that a is much more readable. And at str is minor equal than z. So basically I'm saying if the char pointed is lowercase char, alphabetical char of course, what do? So if I have the char a, it has to be written 1 time, right? On the contrary, if I have the char z, it has to be written 26 times because it is its index, right? So I can say that a is my base value, quote unquote, base value is my 0, okay, in my search. Every time I get a char, I just do that char x minus a, okay, minus a. For example, if I have b, which is 98 minus 97, what do I get? I get 1. So b has to be repeated 1 time, but it is not totally correct. So I have to add 1. This is the formula that gets me how many times a char has to be repeated. You understand this point? Here I have b b minus a is equal to 1 plus 1, 2. So b has to be repeated 2 times, because these at the end of the day are just numbers. Okay, 97, 98. This is the formula I'm gonna use. So it's gonna be b minus a plus 1. I repeat to you ad nauseum that, as you can see from here, these are a and b. Okay, cool. Given that I want a special function that is gonna print x amount of times the char. So put x chars. Very bad naming, I would say. Put n chars. And as an input, I give the char I want to print, which is at str, of course, and the number of times, I repeat to you, is going to be at str minus a, which is 97, right? A in lowercase, because here we're doing with lower cases, plus 1. Okay, semicolon. Else if, same thing, I can just copy past this boy here. I do it like that, but I just change it with uppercase here. And then that's the same idea, right? Put n chars. This time I'm dealing with the upper cases. So str, I have at str minus uppercase a, which is 65, plus 1. Of course, this program deals only with alphabetical chars. So upper cases, lower cases, all the things which are not alphabeticals, we just write them as they are. So I say else, you just write in the standard output file number, you write the string 1. As you can see, I only write str because I don't need to dereference. I don't need to get the char itself. Write once a buffer, once a pointer. And then at the bottom, I just need to increase str, right? So plus plus str. I'm going to increase the pointer itself. All right, I think we are ready for this loop. So this is the main function. We are going to do stuff only if we have one input coming from the command line. Here I have 2 because the first one is always the path of the process, basically .a .out. Here I just invert 2 equal AC because it's fairly common to make this kind of mistake. Basically you say AC is equal to 2. This is an assignment and this is okay for the compiler, so this is not good. This is just a trick to avoid these tedious bugs. Now I have to implement my put n chars, right? So I'm gonna do the prototype at the top, so void, because this is a function that doesn't return anything, it just performs an action. So put n chars as an input takes a char called c, and then takes an integer, which is how many times we have to write that specific char. So I can call this times, semicolon. This is the prototype, of course. I'm gonna copy this, and at the bottom, I'm gonna implement the function, okay? Because this is a trick to have the main at the top. Here it's fairly straightforward, right? So you say, while I have times, so I can say times, open, write in the standard output 1, the address of C, because I need a pointer here, 1. And then I just decrease times, but here I understand that it's not the best way to write, so I do just decrease times directly inside here. Of course, this is the postfix decrement, right? For example, here if I have the value 3, I access the loop 3, 2, 1, 3 times, right? That's why I have the postfix decrement. This is going to become false once we reach the value 0. That, of course, is for falsehood. So put n chars is here. That's all there is for put n chars, a function that is able to print this amount of chars. I think that's it. Let's try to launch and check for eventual bugs. So it's easy. So gcc repeat alpha, and we are gonna launch with hello. It seems like it's working. We do something simpler because I don't want to count all this stuff. A, B, C. So I have 1 A, 2 B's, 3 C's. You see how it works? 4 D's, 5 E's, and so forth. Okay, and that's the way it works. Of course, if I have 2 inputs like that, just a new line. All right, it seems like everything is working. Now we understand better what is going on. Here, basically, you understand, all right? We have a simple formula to get the amount of times we want to write a code. Then I think there's nothing particularly important to understand. Well, you just have to understand the concept of prototypes. This is just a trick. I recall to you that this is just for the compiler to understand how it has to prepare the memory. Basically, we can even forget about the name of the variable because the compiler has just to know how to prepare the memory slots, quote unquote. This is It's gonna take too much time to explain, so I won't. Just this is for the compiler, okay? So we go out. As you can see, we can do the same operation as before. So GCC repeat alpha, a.out with nothing, a.out with high. And you see it works as well. So make sure you understand how argument counter, argument vectors, how all this stuff works. As you can see here, I use AC, you usually see argc, but the name is totally not important. You can write also puppy or whatever you want, because the most important thing is the position. The name is totally influential. Okay, all right, my friend, that's it for this exercise. Thanks for watching. Enjoy.